There are animals that look like nature spent a quiet afternoon polishing them. And then, there's the giraffe. The giraffe looks like someone grabbed a regular mammal, pulled on stretch in every direction, and then hit save anyway. It shouldn't work. The neck is too long, the legs are too tall, the heart is under ridiculous pressure, and the whole thing walks around dressed in a patchwork coat like a living abstract painting. And yet, somehow, this is one of the most finely tuned animals on the planet. If you just glance at a giraffe, it almost feels like a visual joke, like a creature designed by committee. But every strange detail on this animal has a reason. The purple tongue, the tiny horns, the way it bends to drink, even the fact that its closest cousin lives in a dark Central African rainforest. None of that is random. And behind the cartoon outline is a much darker twist. While we've been busy being amused by giraffes, they've been slowly slipping into what scientists are calling a silent extinction. To see how we got here, you have to start where giraffes spend most of their time, with their face buried in trees. Giraffes are leaf specialists living in a world of barbed salad. They're ruminants, which means they have a 4-chambered stomach and do that very glamorous thing of sending food down, fermenting it, and then bringing it back up for another round of chewing. It's efficient, even if it sounds like something you'd rather not watch in slow motion. Plant material goes into a huge fermentation tank, microbes break it down, and later the giraffe calmly pulls a half-digested mouthful back up like round 2. Their favorite snacks are often the leaves of acacia and other thorny trees, basically trees with security systems installed. These branches are lined with long, sharp thorns, the plant equivalent of scattering tacks on your salad bar. Giraffes aren't just shoving their faces into that mess and hoping for the best. Their entire mouth has been redesigned to make weaponized salad edible. On the top jaw, instead of a row of front teeth, giraffes have a thick, rubbery dental pad. The lower front teeth press leaves against this pad like a built-in cutting board, stripping foliage off the branches with surprising precision. Their lips are tough and flexible, able to thread between thorns, fold around a twig, and pull just the edible parts off without turning their own face into a pincushion. Think of it as trying to pick M&Ms out of a bowl of thumbtacks, except you are the bowl, and the thumbtacks are sharp enough to matter. Then there's the tongue, a star of the show all on its own. A giraffe's tongue can be around 18 to 20 inches long in adults, and it doesn't look like the polite pink tongue you're used to. It's usually a dark purplish black, which isn't a goth phase. That pigment likely helps protect it from sun damage while it's hanging out in the open, wrapping around branches for hours a day. The tongue is prehensile, which is a fancy way of saying it behaves like an extra hand. It grabs, curls, pulls, and even helps groom the giraffe's face and ears. It also spends so much time outside the mouth that it has to be as tough as it is flexible, the biological equivalent of a heavy-duty work glove that can also tie a knot. When nutrition is hard to come by, giraffes add something even stranger to the menu: bones. They'll pick up old, weathered bones in their mouths and chew on them, not for the flavor, but to extract extra calcium and phosphorus. It looks unsettling, this elegant leaf eater gnawing on skeleton pieces out in the open. But in mineral-poor landscapes, those bones are basically a supplement aisle. All of that chewing, stripping, and second-round snacking is only the beginning of the giraffe's engineering problem. Because once the food is in, the real challenge is moving blood, not leaves. Imagine your heart being told it has to deliver blood up a 5 to 6 meter tower every single beat, and then deal with that same column of blood sliding back down whenever you look at your feet. That's the giraffe's daily life. In order to get a normal blood pressure at the brain, similar to other large mammals, the giraffe's heart has to generate a much higher pressure at chest level, roughly about double what we'd expect in a person. If a human walked around with giraffe-level blood pressure at the heart, they'd be in serious trouble. Giraffes are not in serious trouble because their whole cardiovascular system has been rewritten for this extreme situation. Their hearts are thick-walled and powerful, designed to pump hard and often. Their arteries are unusually tough and muscular, so they don't balloon under that pressure. And the veins coming down the neck are equipped with valves that act like tiny traffic lights, stopping blood from rushing up or down too quickly when the giraffe raises or lowers its head. You see this most clearly when a giraffe goes for a drink. To reach the water, it has to spread its front legs out wide and drop its neck in a move that looks like a yoga pose invented by someone who didn't like their spine. In that position, its head is suddenly much lower than its heart. Valves and vessel walls work together to keep the blood flow controlled so the brain doesn't get slammed with pressure when it's down, or starved when the giraffe slings its head back up. Even the legs are involved. Giraffes have strong, tight connective tissues around the lower legs, Think of them as built-in compression socks that help prevent fluid from pooling in their extremities under such high pressures. Recent research suggests those very long legs aren't just there to look dramatic. By raising the heart higher off the ground, they can actually reduce the energy cost of pushing blood up the neck, helping the system run more efficiently overall. It's not just a tall body, it's a vertical plumbing solution. But if you're going to build a super pressurized skyscraper-necked animal, at some point you have to answer one uncomfortable question. What else is that neck for? If you've ever seen two male giraffes fight, you know the answer is weaponry. Male giraffes engage in a behavior called necking, and it's exactly what it sounds like, only heavier. They stand side by side, spread their legs for balance, and swing their necks like sledgehammers, slamming their heads into each other's bodies. The impact point is often those little horn-like structures on their heads, called ossicones. In a casual sparring match, it looks almost slow and lazy, like they're just gently testing each other. In serious fights, the blows are powerful enough to bruise, injure, and in rare cases, bring a rival down. Ossicones start as cartilage and gradually turn bony, staying covered in skin and hair. Females tend to have slimmer ossicones with little tufts of fur at the top, almost like fuzzy antennas. Mature males often have thicker, more knobbly ones that look like someone left extra bumps in the mold. Those extra bumps turn each swing of the neck into something more like a mace strike. It's not exactly a graceful ballet. It's more like two living wrecking balls politely taking turns. This behavior feeds into one of the biggest debates about giraffe evolution. For a long time, the classic explanation for the giraffe's long neck was all about food. The idea was simple. When trees are heavily browsed, the animals that can reach the highest leaves get an edge. Over many generations, giraffes with slightly longer necks did better, ate more, and passed on their genes, stretching the species up into the canopy. Then came the necks for sex theory. According to that idea, long necks evolved primarily because males use them as weapons. If a longer, stronger neck wins more fights, that male wins more access to mates. Over time, necks get longer not because of leaves, but because of love. Well, competition for love. Fossils of ancient giraffid relatives with heavily armored skulls and stout necks seem to support this, showing that weaponized heads were a thing long before modern giraffes appeared. The reality is probably messier and more interesting than either explanation by itself. Browsing high in the canopy likely mattered. Winning fights for mating opportunities likely mattered too. But then you have a complication. Female giraffes don't fight the way males do, and yet their necks are also long. That suggests multiple pressures acting at once. Feeding advantage, sexual selection, predator awareness, all nudging neck length upwards over millions of years. Evolution rarely gives you a single neat reason. It prefers a group project. Of course, evolution didn't stop at the neck. It rewired the entire way giraffes move, sleep, and even arrive in the world. Watch a giraffe walk in slow motion, and it looks like its front half and back half got different instruction manuals. Instead of moving opposite front and back legs at the same time like a horse, a giraffe uses what's called a pacing gait. Both legs on one side move together, then both on the other side. It gives them that rolling, almost boat-like glide as they move across the landscape, as if the top and bottom halves are slightly out of sync on purpose. When they decide to run, though, the awkwardness disappears. Their stride stretches out. The front and back legs work like a kind of living suspension system, and they can hit speeds around 35 to 37 miles per hour. For something that looks like a fragile stack of limbs and neck, a running giraffe is shockingly fast. Sleep is another place where the giraffe's life feels a little extreme. In the wild, they sleep very little, sometimes just a couple of hours in short bursts spread through the day and night. Lying down and curling their neck back to rest their head on their body is vulnerable. It takes time to get back up, and time is not something you want to waste when you might have lions in the neighborhood. They will sleep standing up too, dozing in that towering posture, eyes half closed, still alert enough to react if something moves where it shouldn't. Even birth in giraffes is designed around the realities of being this tall. After about 15 months of gestation, a giraffe calf enters the world the way everything else in its life will happen, with a lot of vertical drama. The mother gives birth standing up, which means the calf drops roughly 1.5 to 2 meters to the ground. It sounds harsh, but that fall helps clear the lungs and kickstart breathing. Within an hour or so, the calf is usually standing, wobbling around on brand new stilts. Not walking isn't an option. On the savannah, mobility is survival. For a long time, people like to say that giraffes are almost silent, as if an animal that strange had decided it had said enough just by turning up. In reality, giraffes do vocalize. It's just that much of their sound lives low, soft, and often at frequencies we weren't paying attention to. Researchers have recorded low humming sounds, especially at night, along with snorts, grunts, and cough-like calls. It's the social soundtrack of being a giraffe. Quiet, subtle, and easy to miss if you're not listening closely. When you watch a giraffe standing under a flat-topped acacia at sunset, browsing calmly, it looks like it has always been there and always will be. It feels permanent, like a punctuation mark in the African landscape. But the story the science is telling us right now is that this is not guaranteed. This animal's future depends on things as small as how we farm, how we travel, and what we choose to support with our money and attention. The next time you see a photo or a video of a giraffe, remember everything that had to line up for that moment to exist. The bones stretched into legs and necks. The heart that learned to push blood against gravity without tearing itself apart. The tongue that became a half hand, half shovel, darkened against the sun. The fights won and lost by swinging heads like wrecking balls. The calves that dropped headfirst into a world where standing quickly could mean the difference between life and being a statistic. Giraffes are not just funny-looking animals in the background of safari footage. They are the end result of millions of years of improvisation, problem-solving, and risk. We're living in the chapter where the question is simple. Do we let a silent extinction keep creeping forward? Or do we decide that the strangest mammal in the neighborhood is worth the effort? Somewhere out there, right now, a giraffe is doing what it has always done, leaning into a thorny tree, wrapping that dark tongue around a spray of leaves, chewing twice, scanning the horizon with those big, calm eyes. The least we can do is decide that the story doesn't end there.